Assalamualaikum warahmatullahi wabarakatuh, and hello to all viewers. In this video, we would like to talk about automobile ignition circuit application. Before straight into the topic, let me introduce myself. My name is Muhammad Hazwan Firdaus bin Muhammad Hazli. I study at University Technical Malaysia Melaka in electrical engineering, robotic and communication. The purpose of making this video is for my subject, which is Advanced Electrical Circuit. In my group consists of 5 team members, which is Harith, Aiman, Afiq, Hamza and myself. Okay, before we slide into the main topic, as I mentioned before, first of all, we need to know what is a high pass filter. So, in that case, I will explain the basic of high pass filter. Okay, first, a high pass filter thus is just the opposite of a low pass filter. The purpose of high pass filter is to offer easy passage of a high frequency signal and difficult passage to a low frequency signal. Okay, as one might expect, the inductive and capacitive version of a high pass filter are just the opposite of their respective low pass filter designs. Okay, in other words, high frequency signals go through much easier and low frequency signal have a much harder getting through the signal, which is why it is called high pass filter. High pass filter can be constructed using resistor with either capacitor and inductor. A high pass filter composed of a resistor and capacitor is called a high pass RC filter, and a high pass filter with a resistor and inductor is called a high pass RL filter. Okay, that's all for the explanation of the basic high pass filter. Thanks.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azabir Uthman and I will continue to explain about high pass array filter. Okay, for the first one and the most important thing is a high pass array filter is a filter composed of a resistor and inductor which passes through high frequency signal. The most important part to build the filter is the inductor need to place in parallel to the power source entering the circuit. Like we already know, an inductor actually is like a capacitor because it is a reactive device. The function of the inductor is inductor offer different resistance to signal input into them of a different frequencies. Inductor pass low frequency signal with very little resistance while offering great resistance to signal of high frequency. Okay, so that's why the low frequency signal pass through very easily without any attenuation, and high frequency signal are either completely blocked or greatly attenuated as output. Okay, that's all from me. Thank you, ma'am.
Assalamualaikum and salam sejahtera. My name is Muhammad Aiman bin Ismail, and today I would like to explain a little bit about the automotive ignition system. The purpose of the ignition system is to generate a very high voltage from the car's 2-volt battery and to send this to each spark plug in turn, igniting the fuel air mixture in the engine's combustion chambers. The ignition coil is nothing more than a step-up transformer. The automobile ignition system is also known as the charging system and also known as the voltage generating system. We use the inductor to be the ignition coil. When a current passes through a coil of the wire wound around a soft iron core, a magnetic field is produced. In the ignition coil, a few hundred turns of relatively heavy wire are wound around an iron core. This becomes the primary coil of the transformer. Thousands of turns are wound over the primary coil with much more finer wire. This becomes the secondary of the coil. There will be more resistance in the secondary coil than the primary coil because it contains so much more wire. Being made of many turns of wire, the primary and secondary coil winding have an appreciable inductance. Inductors have the property that an EMF is induced across the inductor when there is a change in the magnetic flux inside the inductor. A change in current produces a change in magnetic field. A back EMF will be produced too because it opposes the voltage of the battery, pushing the current through the coil. Thus acts to oppose change in current. This will charge the inductor faster. The ability of inductors to oppose rapid change in current make them useful for arc or spark generation. The secondary of the ignition coil naturally resonates at a particular frequency, and one can maximize the energy transfer from the primary to secondary by driving the secondary at its resonance. We just wish to adjust the primary coil resonance frequency to match that of the secondary. That's all from me. Thank you.
Assalamualaikum and hi. So before that, I will introduce myself first. I am Muhammad Arbinawi. Today I will explain to you about RL circuit and how to find natural response and tau. So as we know, the general formula of natural response or initial current is IT equal to I naught exponent negative T over tau. T is represent of in time. So the formula of tau is tau equal to L over R. So to solve this circuit, we have two steps: T before 0 and T after 0. So the first step, we must find the I naught T before than 0. So the first we look the switch T equal to 0. The switch we open up. So we can see the T before than 0. The switch is closed and the circuit will connected. So if the circuit connected, the current will flow and affect the inductor. Inductor in DC circuit will be short. Like this. Any resistor that parallel with short, it also will become short. So we can conclude that the circuit will become like this. So the circuit will become like this. So we have to find I naught. I naught is I equal before the 0. I naught is a flow in this one. So as we know, the short circuit, the voltage V naught is equal than 0. So to find the I naught, we just use Ohm's law. I naught equal to V over R. So V is equal to 12 divided by 60. So the answer will be 0.2 ampere. So after the first step, we have find the I naught is T before than 0 is equal to 0.2 ampere. So we go to the next step, T after than 0. So T after than 0. So T after than 0, the circuit will become like this. So before that, we must look at this circuit. So this switch, T equal 0 or after, the switch will open up. So this circuit will be in open condition. So we just take the value of 3 millihenry and 8 ohm. So this is the 60 resistance will be not function because the circuit in open condition. So the circuit will become like this. So to understand this circuit in free source, either free source or step response, we just look the circuit T after the 0. So if T after the 0 does not have any DC supply, we can conclude that this circuit in free source RL circuit. So we have to find the tau. So we know that the tau is equal to L over R. So the L is 3 milli and divided by 8 ohm. So the answer will be 0.375 second. The tau, unit of tau in second. So we have found the value of I naught and the value of tau. So the both of this value we take and put at this initial general current, in this general current. So the formula for initial current is IT equal to I naught exponent negative T over tau. So the value of I naught is 0.2 exponent negative T per tau. Tau is equal to 0.375. So 1 divided by 0.375 is equal to 0.2 exponent negative 2.67 T. After that, to get the value of charging of RL circuit, so as we know, the full of this waveform is 5T, one full length. So the value of tau in charging is 0.632 multiplied by I naught. So we have found the value of initial current, this one. This value of initial current, it is in discharging waveform. Discharging waveform like this. So to find the value of tau in discharging waveform, so as we know, tau is in discharging is equal to 1 divided by exponent of 0.368 divided minus 6, sorry, 0.368 multiplied by I naught. So this is value for tau. This is value for I naught in tau, in 1 tau. Yep. So the value of I naught is 0.368 multiplied by I naught. So we just take one straight line and go down like this, and we have found the value of tau in discharging waveform. So one full discharging RL free source circuit is 5 tau. So that's all from me. Explain about this free source RL circuit. So thank you watching my presentation. Although my BEEI is not good, but thank you and see you again.
My name is Muhammad Afiq bin Ahmad Fauzi. For the conclusion from this video, I would like to recap 4 things that importance from what we have learned. Number 1, what is a high pass filter? So, a high pass filter is a filter which pass high frequency signals and blocks or impedes low frequency signals. Number 2, what does a high pass RL filter mean? A high pass RL filter is a filter composed of a resistor and inductor which passes through high frequency signals. Number 3, how to build a high pass RL filter? The answer for this question is to build a high pass RL filter. Again, just like with the RC circuit, we use a function generator, a resistor, and an inductor. We use an oscilloscope to check the signals. This all we can do it in lab for better understanding. And as we all know, the circuit will form a high pass filter passing through high frequency signals through the inductor. And the last and the most important, number 4, the application as we have learned before. The ability of inductors to oppose rapid change in current make them useful for arc or spark generation. And we know that an automobile ignition systems take advantage of this feature. That's all from us. Thanks for watching.